today we are looking at our fundamental identities of Trig. The first set of those identities is going to be our reciprocal identities. So, this is 5.2c. We are looking at fundamental identities. And our first set of identities we are going to be looking at, I'm going to zoom in for, wrong screen, is our reciprocal identities. We have already talked about our reciprocal identities because we know who is the reciprocal of who, but we are going to put those all down in like an official way. We know that sine is the reciprocal of cosecant. So that means that sine of theta, that color's too bright. We know that sine of theta is 1 over cosecant of theta. Alternatively, we know that cosecant of theta is 1 over sine of theta. So sine of theta is 1 over cosecant. Cosecant is 1 over sine. They are each other's reciprocal. They're best buds.
Like me and your mom.
Not appropriate. Okay. Next one. Cosine of theta is the reciprocal. I cannot talk. Cosine of theta is the reciprocal of secant. So cosine of theta equals 1 over secant of theta. Alternatively, secant of theta equals 1 over sine of theta. Because I'm not thinking. It's cosine. Good eyes. Change that to cosine. Secant and cosine are reciprocals. Miss Ho is a silly goose. A little bit of sleep. Okay. Last one. Tangent of theta is the reciprocal of cotangent. So tangent of theta is equal to 1 over cotangent of theta. And then cotangent of theta is equal to 1 over tangent of theta. Okay, let me make sure I didn't make any other typos. Sine, cosine, tangent, cotangent, secant, cosecant, sine, cosine, tangent, cotangent, secant, cosecant. Okay, we're good. So those are all of our reciprocals. We can flippity-flip these guys and basically use that to be able to get to, if we know sine, we can figure out cosecant. If we know cosecant, we figure out sine. If we know these three, we can figure out these three, and vice versa. Next thing I want to talk about is our quotient identities. So this is another set of identities called our quotient identities. Quotient is division. Can't talk. So in our trig functions, we can know, since sine is opposite over hypotenuse and cosine is adjacent over hypotenuse, we can put sine over cosine. Those hypotenuses will cancel and we will get our tangent. So our quotient identities are that tangent of theta is equal to sine over cosine. So tangent of theta is equal to sine of theta over cosine of theta. Then we know that cotangent is the reciprocal of tangent. So cotangent of theta is equal to cosine of theta over sine of theta. So we can just flip them. So there are 8 identities. They go like super hand in hand. Like these 3 are essentially the same as these 3, and these 2 are essentially the same as each other, just kind of like different forms of the same thing. Any questions about those? All right. So we are going to, in the first 2 examples on your assignment, this is what it's going to be asking you to do. We are going to be able to use these identities to, if we know some of our trig functions, find the rest of them. So I'm going to go ahead and scoot this up so that I have space on my screen. What we are going to be asked to do is we are going to be given sine of theta equals 2 over 5. And cosine of theta equals the square root of 21 over 5. So that's what we're given. It's sine of theta equals 2 over 5. Cosine of theta equals rad 21 over 5. We are then asked to find the other 4 trig functions. So we know sine and cosine. We want to find tangent, cotangent, secant, and cosecant. So we want to find the other 4. You won't necessarily always be given sine and cosine. But that's what we're given in this one. We want to find the other 4. So first one of those that we are going to find is tangent. Tangent is just sine over cosine. So we're going to find tangent of theta by using our quotient identity that tangent is sine over cosine. So tangent of theta equals sine of theta over cosine of theta. So that's going to be 2/5 over the square root of 21 over 5. 2 over 5 over rad 21 over 5. We need to do some major simplification there. How do you divide fractions? What's your favorite local fried chicken restaurant? Wrong answer. How do you divide fractions? Keep flip change. So we keep the first one 2/5, we flip the second one, and we change the multiplication. KFC. Okay. So we're dividing those out. This 5 and 5 cancel. So now we've got 2 over rad 21. What do we need to do with that? Rationalize the denominator by multiplying by square root of 21 over square root of 21. So that gives us 2 rad 21 over 21. Lots of 2's there. Okay, so we have now used sine and cosine to find tangent. Any questions about that thus far? Okay. Now we can find cosecant, secant, and cotangent. We can do that in whatever order. I'm just going to do it in that order. So cosecant is the reciprocal of sine. So cosecant of theta. We can take our sine of theta, which is 2/5, flip it upside down, it's 5/2. Next up is secant of theta. Secant of theta is the reciprocal of sine of theta. Sorry, of cosine of theta. I cannot talk today. Secant is the reciprocal of cosine. So we can take this cosine, square root of 21 over 5, flip it upside down. We're going to have 5 over rad 21. So we will need to rationalize that denominator. So multiply by square root of 21 over square root of 21. And we'll get 5 rad 21 over 21. Last one is cotangent of theta. Cotangent of theta is the reciprocal of tangent of theta. Little tip of advice. We, right here, this is also equal to tangent. Flip that instead of flipping what you rationalized. Because if you flip what you rationalized, then you have to re-rationalize. You have to undo your rationalization. So flip this guy, square root of 21 over 2. Flip before you rationalize tangent. So that's from before we rationalize the denominator of tangent. Okay, questions right now? Okay, so basically you're taking what you know and then using the relationships between your 6 identities to find missing identities. Okay, we're going to do one more thing today, which is our Pythagorean identities. This problem right here should be like numbers 1 and 2 on your assignment. Number 1 and 2 on your assignment should be just like that. Okay, so I'm going to go ahead and move this page. Anybody need this still? Okay, so second thing we're going to talk about today is our Pythagorean identities. So these are more of our fundamental identities, our Pythagorean, cannot spell that word, identities. So these identities are all derived from the Pythagorean theorem. I could sit here and derive all 3 of them for you. I'm not going to because I think that's a poor use of our time. And I think that you guys are just going to believe me that these work. And later when we know more trig, we can derive them. So our 3 Pythagorean identities, the one we're going to use the most, is that sine squared of theta plus cosine squared of theta equals 1. So sine squared of theta plus cosine squared of theta equals 1. Sine squared of theta means sine of theta squared. We put the squared after the sine so you know you're squaring the sine, not the theta. It's just how we write it. Our 2 other Pythagorean identities can be derived from just like doing a bunch of like division and using our reciprocal identities to get to the other ones. Our 2 other Pythagorean identities are that 1 plus tangent squared of theta equals secant squared of theta. So how we would get from here to here is if you divided everything by sine squared of theta. Sine squared of theta divided by sine squared of theta would be 1. Cosine squared of theta over tangent squared of theta, or sine squared of theta would be tangent. 1 over sine would be secant. And then our last Pythagorean identity is that 1 plus cotangent squared of theta equals cosecant squared of theta. So get those 3 identities written down, and then we are going to use them to do a couple different things. the first way that we can use a Pythagorean identity, and this is what problems 3 and 4 on your assignment are going to be, is we are going to use that Pythagorean identity, use those Pythagorean identities. We are going to be given that sine of theta equals 3/5. We are going to find cosine of theta. So, if we're given sine and want to find cosine, we want to use this. Let's say we were given tangent and want to find secant, we would use this. Given cosecant and want to find cotangent, we would use this. So use the right formula, or identity, I guess. And we are just going to plug in sine of theta. So we are going to use the fact that sine squared of theta plus cosine squared of theta equals 1. And we are going to plug in 3/5 for sine of theta. So this here, the formula, the identity has sine squared of theta, so we need to plug in 3/5. We'll have to square that, plus cosine squared of theta, going to equal 1. And then we're just going to solve this like a normal algebra 1 equation. We're going to square out 3/5, so 3 squared is 9, 5 squared is 25, so we've got 9 over 25, plus cosine squared of theta, equals 1. And then we can subtract 9/25 from both sides. 1 minus 9/25 would be the same as 25/25 minus 9/25. 25 minus 9 would be 16 over 25. So I now know that cosine squared of theta equals 16 over 25. And then to find cosine, I would square root both sides. 16 and 25 are both perfect squares. If they were not both perfect squares, you would leave it under a square root if it's asking for an exact answer. So cosine of theta, square root of 16 is 4. Square root of 25 is 5. If it was asking for, if it, like, let's say it was 17 over 25, you would just do grad 17 over 5. Just take the square root if you're able. If you're not, don't worry about it. Leave it under a square root. Okay. We're going to do one more problem. And it's just an application of these Pythagorean identities. And this is what problems 5 and 6 are going to kind of be like. So, problem 5 and 6, if we are told that cosecant squared of cosecant, not cosine, sorry. Of theta, not of theta, sorry, I'm making up an example because there's not one in the book, so I'm like here doing big brain stuff. So let's do cosecant squared of 52 degrees minus cotangent squared of 52 degrees. You're going to say, I don't know how to find any trig functions of anything other than what's on a unit circle or that I have a triangle for. Here's what you're going to do. You're going to go say, okay, I have a Pythagorean identity that involves cosecant and cotangent. I know that 1 plus cotangent squared of theta equals cosecant squared of theta. So I'm going to rewrite that down here. 1 plus cotangent squared of theta equals cosecant squared of theta. I can rearrange this to be cosecant minus cotangent. So I can subtract cotangent from both sides. and get that 1 equals cosecant squared of theta minus cotangent squared of theta. And then I can apply that to know that if this theta and this theta are the same, any cosecant squared minus cotangent squared will equal 1. And the answer to this question is literally just 1. So it's just you using the identities, and the answer to that question is literally just 1. Okay. Any questions about any of the 3 problems we've seen today? Okay. Use those identities. Go ahead and get on and get started working. Let me know if you have questions, if you need help with stuff.